Hello everyone, today I'm going to be talking about voltage, current and resistance and how these relate to each other in a circuit and how we can calculate all of these using Ohm's law. So first off, voltage has the symbol V and is measured in volts. Current has the symbol I and is measured in amps. And resistance has the symbol R and is measured in ohms, which has the Greek letter omega. Kind of looks like a horseshoe. Now we can calculate all of these using Ohm's law. So Ohm's law states that the voltage is equal to the current times the resistance. And we can rearrange Ohm's law to find the current and the resistance as well. So the current is equal to the voltage divided by the resistance, and the resistance is equal to the voltage divided by the current. Now, this is a lot of maths and isn't really intuitive to understand how electricity flows in a circuit. So I'm going to be using an analogy of a water tank to better explain how the flow of electricity works. So imagine we have a water tank, which is kind of like a battery, and we have a pipe flowing out of the water tank. Now, the voltage is kind of like the pressure in the water tank right here at the bottom. So having a little bit of water in the tank only produces a little bit of pressure down here, and increasing the level of water increases the pressure, which would be seen as an increase in voltage. Now, more pressure at the bottom of the tank would produce more flow in this pipe, and the flow of the water can kind of be seen as the current, as a current flows through a wire just like the water flows through the pipe. Now, the resistance would be seen as the thickness of the pipe. So a very low resistance could be seen as a thick pipe, and a very high resistance would be seen as a thin pipe. So let me show you why that is. So very low resistance means there's a lot of flow of water. There's nothing that resists the water. So a thick pipe for very low resistance allows lots of flow of water, while a high resistance is a very thin pipe which doesn't allow much flow for water to go through. Now let's have a look at this in a real circuit, or an example of a real circuit at least. So for our water tank, I'll draw us a battery which has a positive side and a negative side, and then I'll also draw a light bulb, or at least try and draw a light bulb with two terminals as well, and the filament there in the light bulb. Okay, so let me just draw a water tank on the side here. So battery is the same as the water tank, and then we need a pipe to connect the light bulb to the battery. Now, the positive side of the battery is kind of like the bottom of the water tank. It's where the current comes out. So the water flows out at the bottom of the tank. And the same way, current flows out at the positive side of the battery. So we'll just connect that to the light bulb. Now, this is where electricity differs from water a bit. Whereas water would be able to flow with just one pipe connected, electricity doesn't work the same. So electricity actually needs two wires to complete the circuit, and this could be seen as opening the tap. So when there's one wire here, this is known as an open circuit. Now with an open circuit, this can kind of be seen as a closed tap at the bottom. A closed tap. So If we close the circuit by completing it with another wire, allowing the current to flow through the whole circuit, all the way through the light bulb and back to the negative side of the battery, this is seen as opening the tap here at the bottom and allowing the current to flow. So the most important takeaway here is that current needs a completed loop to flow, and it always flows from the positive side all the way through this completed loop to the negative side. Now let's quickly just do an example of Ohm's law by calculating what the current would be inside the circuit. So let's say this battery has a voltage of 5 volts and the resistance of this light bulb, let's say, is 2 ohms. So we earlier saw that the current is equal to the voltage divided by the resistance, which would be 5 volts divided by 2 ohms, giving a current of 2.5 amps. So I hope that was helpful. If you need any other help, just write a comment down below and I or someone else will help you.